there actually is no recovery. It's just like freeing a block normally in ZFS. Is I have to, update the space map that the block is now free before I update the Uber block. And so in ZFS, not only is all the user data pushed out in a given transaction group that has a single Uber block update associated with it, but all the metadata associated with all these user data updates, which in this case would include an update to the DDT structure, all of those are transactionally updated before we update the Uber block. So it's just like everything else in ZFS, it all just kind of falls out.
Go back to that gentleman's question about the quotas. How does snapshot and quotas, user quotas kind of interact? So if I have a user, I have a couple of snapshots.
Yep.
How those?
So the snapshots are, the quota information is snapshotted along with each snapshot. So the user doesn't get charged for the single copies of all the blocks that he has. He only really gets charged for sort of the live version of what he has in the file system. He doesn't get charged on all the back snapshots that the administrator on the user's control may or may not have taken.
Say to place B, you've got to first read it, you've got to make a copy somewhere else, and then you've got to get all the things that point at the old one to be pointing at the new one. And once everyone points at the new one, then you can actually free the old one and call it done. Fortunately, because of the way ZFS works, doing that in a way that's transactionally safe is at least possible. But it is nevertheless difficult because you do have to locate all the blocks that are potentially shared. Of course, dedupe adds yet another dimension to that level of sharing. And so it turns out that just getting this done is hard. It's Matt Aarons is the guy working on it. Incredibly sharp guy, but it is, as I say on the slide, it's subtle, it's racy, it's hard to debug, and it has to be perfect. Because otherwise, you think you've got to migrate all your data, but oops, we missed one, and maybe that one's really important.
And the thing about this is that, so if it's this hard, why bother at all? It's because it's sort of the enabling feature for a lot of stuff people have wanted ever since they heard about ZFS, like device removal, online defragmentation, changing my compression algorithm and having all the previously written data recompressed using this new compression algorithm.
Right. Applying dedupe to an existing pool that didn't have dedupe.
Right.
All of those things require the ability to go over all your data and lay it out in some new way. And the way to think about it is that what it really is doing is taking a one-level model of pointer points to data, and it's inserting a layer of virtualization. And as always, a layer of indirection can solve any problem in computer science. But inserting that layer of indirection can be tricky to do, right? And we actually contemplated, just a little, historical trivia. In the early days of ZFS, you'll notice if you look at our block pointer data structure that there's up to three addresses for each block to deal with what we call ditto blocks, so that data can be, so metadata can be replicated across multiple devices. Those three individual DVAs, the DVA stands for data virtual address. And the original idea was that in fact it would be a virtual address, that we would be doing truly virtual addressing of data, not a one-to-one mapping between it's this device and this offset. And that just turned out, unfortunately, to be just too expensive.
Yeah,
it's really slow to insert that there because every I/O becomes multiple I/Os.
And you can sort of tell why we discarded it, because internally the name that we had for this data structure that provided the virtualization was the bolt-on.
Right.
And because that's just what it felt like architecturally, it's just very awkward.
But where we are is that the basic logic works in terms of on it. We have it to where on a pool that's just sitting there, you can run the BP rewrite code and it will actually successfully migrate everything from one place to another. Matt is currently going through the exercise of debugging what happens as you have more and more concurrency, so it can start to tickle all these little race conditions. And then the last one where it gets trickiest is things like, as you're in the middle of doing this, there's a configuration change of the form, a device is removed, a snapshot is deleted, which can sort of change the relationship amongst data sets, and therefore the set of block pointers have to be evaluated. It's all possible, it's just really tricky.
Shadow migration, or the previous name for this was called brain slug. The idea is, I have some existing storage, for example, on a, competitor's filer or something. And it's a few terabytes. I really want to use this shiny new thing based on ZFS, but really migrating 4 or 5 terabytes kind of takes a while. And having my data unavailable during that migration, not acceptable, because that could be days, and I don't have days to be without my data. So the idea is that with this brain slug, or shadow migration, is that what you do instead is you turn your existing filer into read-only mode, have your new filer with ZFS on it take over responsibility for all the data, and have it proxy for data that hasn't yet been migrated over. So if a request comes into your shiny new ZFS filer for data that hasn't been brought over yet, the idea is that I'll just go read it from the pre-existing filer, migrate it right then and there, and then service the original request. And do this all transparently, so that the initial cutover to my new appliance is nearly instantaneous. And the data is just constantly being migrated over in the background as this migration is happening. So the way it works is it's in the form of a VFS vnode interposer. So, what happens is a request comes in from, say, NFS or CIFS or what have you, to the internals of the Solaris kernel called the VFS vnode layer. And it's there that it will see, has this already been migrated over into ZFS? If the answer is no, then go get it from the shadow copy, read it over, service the request, and update the local ZFS copy. So the basics of this are done. I'm sure Brendan can probably tell you more because some of his neighbors in the office are actually the ones writing the code. And there's some edge cases that have to be added. The initial version is going to be NFS only because that's where this comes up most often. And eventually, because it is VFS vnode interface, it should be a relatively straightforward follow-on project to have it work for non-NFS environments.
And then just a few random things. So one of them is dynamic line expansion. So this is, the support's actually been in ZFS for a long time to deal with if a device changes size, then we can take advantage of that. What hasn't been there is the integration with all the rest of the surround to actually be notified of when that happens and you can act on it. So it's a combination of putting together the hot plug events or the sysevent framework stuff where it says, hey, there was just a change in the size of this LUN, so support was required for that. We had to be, that event gets published, we had to subscribe to that event, then we subscribe to it and say, oh, does the user want this pool to automatically expand, or do they want to have to take an explicit action? If they said auto expand, we go ahead and expand it. And there's just little sort of edge cases they have to be careful with, because we actually, in earlier versions of the code, we would do more aggressive auto expand, such that, like, for example, if you would export a pool and then import it, it's possible that as a side effect of that, that if the LUNs had grown, we would just go off and expand them for you. And we thought we were doing people a favor, but there's cases where it's not. Like, you have a mirror of, say, a 500 gig disk and a 1 terabyte disk. And because the mirror has to be the smaller of the two, the size of the mirror is 500 gig. And then, because of some temporary problem, the 500 gig disk is offline. So now you just have a 1 terabyte thing, and it's like, hey, my LUN just grew. And now you start putting data across the whole terabyte. Then you try and attach the 500 gig side again, and it's like, hey, that's too small, you can't put that here. So you don't always want it to be automatically.
Yeah, it's kind of awkward. And the same thing for if you imagine running this on top of a fiber channel SAN, and the administrator, was like, oops, I expanded the wrong volume. Let me shrink it back down again. Well, ZFS, since if we automatically expand, it said, ooh, look, more space. Oh crap, it shrunk. Now off it goes and gets all unhappy on you. And you don't necessarily want that either. So that's why it's a property, because in some cases, especially until we get device removal all working, you don't want this to be automatic unless you are in an environment where you know that's safe.